All right. Good afternoon, good evening, ladies and gentlemen. Welcome to another series of tutorials with me, Aubrey. This is going to be a very, very interesting lesson. So, even as we start, remember, always remember, all right, always remember to subscribe to the channel, leave a like, comment, share, all right. Don't forget to subscribe because my stats right now are showing me that only 50% of you who watch my lessons are subscribed. So I am requesting that you subscribe and yeah, so support the channel. So we are continuing from where we left off. We talked about the Cauchy integral theorem, all right? And today we're going to look at how questions may come, okay, on the Cauchy's integral theorem and how you can answer them and just have an understanding what they are all about. So this is an example of the question. So evaluate the integral of 2z over z minus 2 dz in this region. All right, we are integrating in a region. So you usually be integrating in a given region. Now, it may look overwhelming, but it is a very, very uh, simple question. All right, it's a very, very simple question. So now, so what do we do? So the first thing is we will need to sketch this graph. So I'm going to explain why later, but the first thing is we need to sketch this graph. And our guide for sketching this graph is this. Okay, excuse me. All right, so this is the formula we should use. So what the formula is essentially saying is, whatever you are given, you should group it with the real parts alone and the imaginary parts alone. Okay, you know that z is equals to x plus iy, so this is where the x is coming from, and this is where the y is coming from, and the h is any other real part, and the k is any other imaginary part, and whatever you have there is your radius, and we still have the modulus. So we can write this in this form. So we're going to say, yeah, so where that this is the center, negative h comma k, I mean to be h comma k, and this is our radius. So here we can write this as x plus iy, this z, then we say plus 1, all right? Then modulus is equals to 1. So now what we want is to have this. We want the real parts alone and the imaginary parts alone. So unfortunately, we only have x and 1 as the real parts and iy as the imaginary parts. So writing that equals to 1 and comparing to this, our h comma k will be negative 1 comma 0 and our radius will be 1. Okay, like that. Then from here we can go on and plot this. So negative 1 comma 0 is our center. Okay, we go on our xy plane there. We locate negative 1 comma 0. As you can see, this is negative 1 comma 0. So now the radius is 1, so we move 1 unit this direction, it will just be on 0, and 1 unit in this direction, it will be on negative 1, 1 unit down, I mean negative 2, 1 unit down, negative 1, 1 unit up will be positive 2, and our circle will be like that. All right, so from here, after you find your circle, you need to find the pores. All right, the pores are points where this function is undefined. The pores are also called singularities. All right, singularities. So this is where this function is not analytic or is undefined. Okay, so we need to find the point where this function is not analytic. Okay, and how we do that is we just equate the denominator, whatever is at the denominator, we equate it to 0. So we say z minus 2 equals to 0, meaning that at z is equals to 2, this is undefined. Okay, so now we need to check now. All right, we need to go back to our drawing here. We need to check, is this function analytic inside here, or does any of the pores exist inside our region there? So we locate where z is equals to 2 is. So z is equals to 2 will be there. This is where somewhere there. This is where z is equals to 2 is. Okay? So since this function, despite it not being analytic at z is equals to 2 here, but since it is analytic everywhere in this region, then the integral will be equal to 0. So, and you are done solving. Okay, despite this function being not being analytic at z is equals to 2, but since it is analytic everywhere in this region, then its integral is equal to 2. I mean, is equals to 0, sorry. It is equals to 0, and that's how you solve. So now, there will be cases where, let's say I'll change the question a bit, I'll modify it. Let's say, okay, suppose we had, this. All right, let me do this. Suppose here we had z plus 2, right? Z plus 2, okay? Z plus 2, okay? Suppose we had z plus 2, then the pose would be at z plus 2 is equals to 0, meaning that z is undefined at negative 2. So we look for negative 2. Where is negative 2? It is right here, okay? It is right here. So since negative 2 is on this line, okay, is on this line of the circle, it means this integral is not analytic in this region because of the pore. This integral is not analytic at z is equals to negative 2 here. Okay, and since this includes the boundary because of the equal sign there, includes the boundary, it means this will not be equal to 0, but another way of finding this. So there is another way of finding if your pores are inside the given equation of integration, or your given circle of integration. If they are inside, there's another way to do it. So, but if they are outside, then the answer is 0. See you in the next example.